Hello team, this is Wes Weimer with another video guide, this time for programming assignment 2, the Lexer. In this particular video we'll use Python and PLY, Python LexYak. We'll cover reading in a file specified as a command line argument, a cool file. We'll download PLY, take a look at the PLY documentation, go over some token definitions, how to break the file up into words, as it were. Talk about line numbers and lexemes. We'll actually do a live submission demo, hope that works. And time permitting, talk about error handling at the end. All right, so one of the first things I will do is go to the assignment webpage, and I've read the whole thing in advance, and one of the bits that I will notice is that I must name the main portion of my file main.py. So let's do that now, and I will start off with some sort of comment. This is a Lexer for cool. PA2. All right. Now, one of the next things that I need to do is read in a file specified on the command line before I can do any processing on it. If I don't remember how to do that, maybe Google will be my friend. How to read in a file into a string in Python. How do I read a text file into a string variable in Python? All right, it looks like I need to call open on it. And possibly save that. I'm going to call that something like file handle. And then once I have that, I could read all the lines. No, I don't like that. Maybe I will just call read. I love it. To get all of the values. File contents. Maybe file handle.read. But I don't want to be reading data.text all the time. Eventually, I will want to be reading something new. But you may recall that I'm a big fan of testing early and often. So let's actually try this out. All right, I like Jane Austen. Let's see if when I run main.py, we read in this data text file and print out the same thing. I like Jane Austen. All right, looks pretty good so far. So now instead of reading in data.text, according to the specification for PA2, I need to read in a file passed as a command line argument. Python, how to access command line arguments. All right. How do I access the command line arguments in Python? Yeah, variable 1, variable 2, variable 3, that's exactly it. It looks like there is a special array variable, sys.argv. And by standing convention, the one that I want will probably be the first argument, counting from 0 in computer science. All right. So let's try this out. If I run exactly the same thing, I actually expect it to choke. All right. Maybe we'll read something like Python or we'll read main.py, but we'll fix up that bug in a minute. All right. Sys is not defined. Well, how do I get sys in something like Python? I guess we'll import sys at the top. Do we like it now? And it's actually printing out the contents of main.py. So rather than argument 0, I would want argument 1. And this time it's going to choke because there is no argument 1, but if instead I pass in data.text, all right, this is pretty good. Indeed, instead of data.text, we'd want to be parsing some sort of cool file in, reading it in as a string and then converting it. So rather than printing its contents, we want to do Lexing. We want to do PA2. And I remember from the PA2 description that I am required to use some sort of lexical analyzer generator like PLY. All right, so maybe one of the first things I want to do is download PLY. I could do this through my web browser, but I'll just do it here through the command line. PLY yields a tar gzip file, which is the old school Unix version of like rar or zip. Right, this is an archive. I could extract from this compressed file. Tar is so old that it predates hyphens as command line arguments. All right. And now we can see this PLY38 directory, which has a bunch of stuff in it. All right. To help me get started, though, I'm going to read along in the documentation. And Python LexYak, it does both Lexing, PA2, and parsing, PA3. Let's just look at the Lexing part to get started. All right. Lex example. The following example shows how lex.py is used to write a simple tokenizer. Lex.py, we may not have that yet. We'll get that there. So we need to be able to import ply lex as lex. And in fact, we're going to just copy a lot of this. Paste mode for VI. We can do it. Copy it into our file. And at this point, we will note portions of this code were adapted from the POY documentation, which I totally can't spell. All right. So they've got a list of token names. You know, this seems like a lot to do for a demo. Why don't we just do numbers and plus for now, just to keep it super simple. All right. So then we don't need minus, times, divide, left paren. You can put them back in later. And they notice, or they say, regular expression rules for simple tokens. This R before a string in Python is often used to mean this isn't just any string. This is a regular expression string. This plus is the character we want. But remember, plus has a special meaning in regular expressions, like A plus is one or more A's. So we've got this backslash before it to escape it, to mean I really want actually plus. And then if you've defined a token with a name like number, you can make a method with a T underscore, T for token, and then this same big name here. So this number here and this one up here, they should be the same word. All right. So T number, this is the regular expression for it. Behind the scenes, they're overloading Python documentation. This backslash D means any digit. I don't know, that seems very complicated. Maybe I don't trust it. Maybe I think cool numbers are 0 through 9 plus. I will put in my own regular expression. And here, you can actually see them converting the value, the particular string that they read in, to an integer, and then storing it in the token value field. All right, that seems fine. This is the Lexing. We'll get to that in a bit. And they also have a rule for tracking line numbers. Whenever they encounter new lines in a row, then they increment this line number variable. Oh, that seems super handy because we have to do this for PA2. All right. And then they have a string containing ignored characters. We call this whitespace, and you're supposed to skip it. And then they have some sort of error handling rule. All right, that seems pretty good. We'll have to handle errors eventually. And then they build the Lexer. All right, well, does this even work? Like, is this code going to pass through Python? It says we can't seem to import ply.lex. And although we downloaded it, all right, let's just take their file lex.py and copy it so that it's right next to our main.py so that Python can definitely see it. And indeed, when we submit it to the grading server, we'll probably need to include it in our zip file because it's not part of standard Python. All right, so now it ran, but we didn't do anything, possibly because after we read in the contents of this input file, we never actually lexed it. Like, we built this Lexer, but now we need to run the Lexer. Ah, man, I don't know how to do that. Let's keep reading in the documentation. All right, so they say that you can give the Lexer some input from some data, and our data we called file contents. Indeed, I'll actually move this stuff down here, I don't know, for better software engineering. So we're going to build our Lexer on file contents, and then we can turn it into tokens, like so. We call a token gets the next token. If there's no token, we break out of this loop. Otherwise, we print it out. All right, this seems pretty good. Now, before we run this, it's worth trying to think about what will actually happen. We had, what was our data file called? Data.text, I like Jane Austen, which is definitely true, but we only have rules for numbers and new lines and that sort of thing. I don't think we have any rules that will capture I or like. So I actually expect our Lexer to complain really early on. Well, let's see how that goes. Illegal character. I like Jane. You're right. None of those were matched by rules. So instead, I'm going to change my data file to something like 2 plus 2, because I think we can handle that one. All right. And this time, instead, we get these Python Lex token objects. We've got the number 2, and then we've got this 1 and 0. These are actually likely the line number and the column. All right, that seems pretty good. But the specification for PA2 says we have to print it out a different way. We have to first print out the line number and then the sort of the token. And we saw earlier down here, instead of printing token, that the line number was called line no. So let's see if this works. 111. Well, it's hard to tell because I put all of my tokens on the same line. What if I put this one on line 2 and this one on line 4? So now we should expect to see 124. 124. All right, looks pretty good. We are printing out the line number. All right, but now, one of the next things we need to do is figure out this part here, like number or plus. And reading back in the documentation, it looks like we've got a token.type, token.value. All right, so let's try. Next, we will print out curse you, Python. All right, there we go. We will print out the token type on the next line. So we see now 1 number, 2 plus, and 4 number. And that's getting pretty good. But again, the PA2 documentation gave different words for these. Like instead of number, I have to use integer, right? And instead of plus, I have to use plus. But these are both lowercase. So let's go back and see about changing these to integer and plus and see if PLY is still happy. 1 integer, 2 plus, 4 integer. All right, that seems pretty good. But if I were to instead move this data text file to a data.cool file and run cool and ask it to lex up data.cool, we're very close. We've got 1 integer, they've got 1 integer, but the reference Lexer prints out the actual value of the integer. So we'll need to do that too. And I don't know, we'll cast it to a string just to be safe. So now when we run Python on main.py and we have our data cool file, we've got 1 integer 1, 2 plus plus, and 4 integer 2. Man, that looks pretty awesome. Our output, let's just call that. And for a little testing, I'm going to diff our output against what we got from the reference. All right. Oh, and they're not exactly the same. 1 and integer match up, 2 match up, plus matches up, but we're printing out this plus again when we shouldn't. It's complaining about every line. If I have it ignore blanks, there we go. Now it only complains about this plus on line 5. This diff format is hard to read. I like, I don't know, unified diffs, something like that. Yeah, now I can see where the problem is. It's this plus right here. All right, so we only want to print out the value some of the time. I'll use a particular approach for that. If token type is in integer, then I will print it out, otherwise I won't. And I could put in, maybe there's some other stuff I'll put in this list later. Let's see how this goes. All right, and now we've got our integer 2, 2 plus, and 4 integer 2. This looks pretty good, except that we are writing to standard output, and the problem specification requires us to write to a file. Indeed, a file that's very similar to the one we read in, like if this was sysargv1. So instead of printing all of these, we'll need to write to a file in Python. I've totally forgotten how to write to a file in Python. How to write to a file in Python. Save me Stack Overflow or the actual Python documentation? No. All right, so file, reading and writing to files. All right, so I can open some file handle for writing. And the name of the file that I'm supposed to open, it's not a work file. Right? It's, we had cool, we do something like this. We just append Lex to it. Right? And we'll just call this out file. All right. And now Yeah, that's all good. How do I actually write to it? Read line, so much reading. All right, I just call f.write. So instead of printing, I could do all of this outfile.write stuff. That seems pretty good. Usually once you open a file, you need to close it at some point later. All right, it's just f.close. So then down here, oh, not lexer.close. Well, maybe, but outfile.close. All right, so now let's see. We'll remove data.clx, and I'm going to run my program on data.cl. Outfile.write expected a character buffer object. All right, what if I cast everything to a string before trying to write it? Ah! Oh! Well, it looks like one difference between write and print is that write doesn't put in new lines unless you really ask for them. So no problem. I can totally do that. Oh, I have to rerun it. This is why they pay me the big bucks. And now it actually looks pretty good. 1 integer 2 plus. Indeed, it's close enough. This will be a big gamble. And we might actually try submitting it. If there are very simple test cases on the server that are just like 1, 2, and 3, we might even get them right at this point. The mind boggles. So we'll make up a zip file on wrw6y, and we need to put all of our Python files in it. And I totally can't spell zip. Ignore the man behind the curtain. All right, so we've made our zip file. And now over here, we want to go try to submit it. And now we're submitting for the Lexer. We want to make sure that I'm going to be able to... I totally found the file. And now let's just submit this and see what happens. Oh, I need to log in, and then probably it's going to choke the first time, and then I'll log in again. Okay, you need to submit a smaller file, blah, blah, blah. I love our submission server. I really do. All right. We're going to submit this file. Oh, hey, this looks pretty good. We are passing this test that says int123 on one line. I wonder why. Because we handle integers. And then there's int123 on multi-line. We did that. Oh, and ints and pluses, we're passing that too. But most of the rest of the things we're failing. Oh, file with all whitespace we pass. I love it. But we appear to be failing all of the negative test cases. Well, why is that? One reason, if we go back to assignments, is that we're supposed to do something very specific for error reporting. Let's go try it out. When there's an illegal character, we're supposed to write, what is it? Error colon line number colon Lexer, and then we can say whatever we want. And I never remember how print works in Python. Maybe this will work. Error, illegal character. And then we're actually supposed to stop after the first error. Oh my gosh. So we want something more like that. Now to test out an error like this, we need to make a file with an illegal character in it. For us, something like yada, y, I don't know, instead of Jane Austen, we can do Charlotte Bronte, would be an illegal character because we don't have a rule for this. So let's go see what we say now. It says illegal character y, but we created this data CLX file with partial input up to that point. And part of the specification is if there's an error, we can't make any legitimate output. We only have to output the error. Now we've seen that sort of thing before, maybe when we were doing the Rosetta assignment. So what I probably want is, instead of writing to this out file immediately, I'll make some output string and add onto it. And there's a better, more Pythonic way to do this, but hey. Right. out string, and then close it. All right. So let's see if this change works. We'll remove the yada. And now we're going to also remove this entire CLX file, and we will run our Lexer on data.cool. All right, that looked pretty good. But now once again, I'm going to remove data.clx. I'm going to go back in here and put in some illegal characters. And now I'm going to run our Lexer again. And it says illegal character. But we never made the output file. So now we're following this specification more closely for the program. Now it's worth noting that these aren't illegal characters for cool. It's worth learning with your editor how to actually put in some weird illegal character. But that's a story for another day. All right, so now I will remove our zip file. I will re-zip it up. And let's see about resubmitting it. I want to choose a file. I want to choose this file. It changed, so just in case. We're going to remove our old output, and we'll resubmit it for just testing and see if anything works better. All right, so we're still passing some of the tests we passed before. Oh, but now we also pass this negative test, illegal character on line 1, and also we pass illegal character after an integer on line 2. Great. So now what you would do for the rest of the assignment is just go through for all of these other tokens, at, case, class, color, comma, colon, comma, divide, blah, 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 and add regular expression rules for them. Like where we have plus, you could also do, minus, you would add it to the token list, that sort of thing. And you want to pay special attention to comments and strings and some other tokens that will have very complicated regular expressions. Good luck with PA2.